Hey everybody, welcome to our new name of the channel, right? We call it Conservative Engineering Academy, right? That's the new name for the channel now. And the reason why I changed is because I want YouTube and everybody know that I am a conservative engineer. I am not, just almost every other person that pop up in the internet and want to be, politically correct and all that stuff. Of course, when I will be talking about mathematics, about engineering, I'm not going to be teaching you, what you should be, to come and join me. No, that's not going to happen. But I want to make that my point clear that I am a conservative engineer, and every once in a while, probably the word Jesus or God might come up on this channel. I know this is not related, but I want to let you guys know of who I am, right? So let's do some problems, and I will do some problems out of this book, and it's called First Course in Differential Equations, right? And it's kind of old type of book, and we will do two basic problems. We will do, the first one is going to be dy dx equal to sine 5x, right? And the second one is going to be dx plus e to the third x dy equal 0. Right? So this is going to be number 1, and this is number 2. Okay, so we will still be doing separation of variables, right? So here we can just separate the variables, right, by just multiplying dx times sine of 5x, right? So we have dy is equal to sine 5x dx, right? So now that I have this, right? I can actually integrate on both sides, right? Because my first step is already done, separate the variables, right? I have a dy on this side and I have a dx on this side, right? But I have to integrate on both sides. That is my next step, right? So the next step is what? Is integrating on both sides, right? When I integrate dy, that becomes y, right? When I integrate sine, right, it's negative cosine, right? So it's negative cosine, right? Now, when I integrate the argument of a trigonometric function, basically I am dividing by that argument, by the coefficient of the argument, right? So in other words here, because this is the coefficient of the argument, I will say, okay, 5x, right? And I am dividing by 5, right? And of course here I get a plus c, a plus a constant, right? Now can I clean this up a little bit? Of course. I just pull that out and I get what? I get y equal to 1 negative 1/5 cosine of 5x plus c. Okay, so that's number one, right? Not too bad, right? This is not too bad. Now let's do this one. This one is a little more challenging. And the reason why it's a little more challenging is because we have a 0 here, right? So my first goal is going to be kind of separate the variables, right? So if I separate the variables, I do what? I do negative. I always like to have my y on the left side. My y on the left side and my x's on the right side. If you feel comfortable doing the y's on your right side, I always like the y on the left side, so actually I can, it look, for me it's kind of easy to say, okay, this is y, this is x, and I know at the end of the day I have to kind of make it y equal to x, whatever variable I have in the next side of the equation anyway, all right? Now, what I do here, I subtract dx. Subtract dx, right? So, subtract dx. Now I have what? I have an e to the 3x, e to the 3x dy equal to negative dx, right? Okay. The next step is going to divide. I want to eliminate. I want to have my dy in this left side, right? So that means I have to get rid of that e to the 3x move it somehow to the other side. And the only way that I can do it right here is by dividing, right? So I divide by e to the 3x, right? Divided by e to the 3x. When I divide by e to the 3x on both sides, this cancels out, right? And I get dy equal to dx over negative dx. Be careful with the signs. E divided by e to the 3x, right? So, okay. So now, what will be my next goal? I can clean this up a little bit here, and I can bring this up and rewrite it, right? I can bring this to the top and make that exponent negative, and I can say, okay, I can say dy equal to what? Equal to negative hold on a sec. I had to bring this one up, right? So this is e to the negative 3x dx, right? So what I did was I brought that up, and when I brought that up, that becomes, the exponent becomes a negative, right? So now I can do the rest of the problem. I can integrate on both sides, just rewrite it here. So dy equal to e to the negative 3x dx, right? And I integrate on both sides. Right? So when I integrate on both sides, that becomes a y, right? Right side becomes a y, and I'm sorry, the left side becomes a y, the right side becomes what? Becomes, when I integrate that, I am just dividing by that exponent by the 3, but remember, it's a negative 3, right? Which is going to be what? It's going to be a negative, right? And it's going to be, I can put a parenthesis like that, it's going to be e to the negative 3x divided by negative 3, right? Plus a constant, right? So now, how can I clean this up? Well, I can clean this up by simply dividing those signs right there, right? Dividing these two signs, right? Right? And then I get what? And I can factor out 1/3 out. If I factor 1/3 out, the answer is 1/3 e to the negative 3x plus c. Alright, that is the answer for that differential equation. This one was a little more challenging because we had to kind of move stuff around because this was 0, right? But this is still doable. All you gotta do here is separate the variables. When you get the variable separated, then becomes just integration, right? So that's it. That's it for today in this short video, right? So we have two basic problems on differential equations. We have what is called general solutions for the differential of equations, right? In this case, we got that. We got this answer for this problem right here, and we have that answer for this problem right here. Thank you for watching.